So I haven't made it too far through this thing. I found another mistake. I had to redo number 4. You won't actually see the mistake. Anyways, $3.08 made of pennies, dimes, and quarters. Think of that as 308 cents, okay, instead of $3. You have 38 coins, so the number of pennies plus the number of dimes plus the number of quarters must be 38. A penny is worth a penny, a dime is worth 10 of them, and a quarter is worth what? 25 cents? Anyways, they add up to 308 cents. It'd be really nice if this thing was actually solvable like that. I didn't think that'd work. Anyway, sorry, just had like a little brain fart there. I wanted to see if it could be done any easier. Anyways, you have 3 times as many pennies as quarters. 3 times as many pennies as quarters. This is the line that always gets people. The 3 times as many pennies as quarters. That's just an example. 2 quarters. That's 6 pennies, right? Because you triple it. It's the pennies you have to triple, not the quarters. For equality, you have to have 3 pennies for every quarter. I hope that you get that. Now, when I come over here, I've got to take that thing and manipulate it. Notice how I have PDQ, PDQ. So I'm going to have to subtract the Q, be equal to 0. And because I'm going to use a TI-84 in here, I have to actually introduce a placeholder for dimes. So 3P plus no dimes minus a quarter is 0. Now, why did I do that? Because you get to use your TI-84 for this. Make your matrix 1, 1, 1, 38, 1, 10, 25, 308, 3, 0, negative 1, 0. And what you can do is you can hit that thing with that reduced row echelon form, RREF. So anyways, back to my calculator. Second matrix edit. That was second matrix edit. I've got a lot of this one typed in, and you should be trying to see if you can do this on your own. See my old matrix in here from the previous example that I had that did not work. So I had to go back and fix it. 3, 0, negative 1, 0. And hopefully I created this problem right, or I'm just going to quit today. So after my matrix is in, second matrix, math, look for REF. It's 2 below that cum sum function. Press enter. Second matrix, choose matrix A, press enter again. Here's our resulting matrix. And it doesn't make a lick of sense. This should be working. Why is this not working? 38. 1, 10, 25, 308. You don't see any mistakes at home, do you? 3, no dimes, negative 1. Oh, because I'm an idiot. It says you have 3 times as many pennies as quarters. This is right. See, I just made the simple mistake that I accused y'all of making. That's how tired I am today. Since you have 3 times as many pennies, for equality purposes, it's the quarters you have to triple. 3Q. P equals 3Q. Because if I had 12 pennies, that would be 3 times as much as 4. I'd have to triple it for equality. So the thing I was getting on to y'all about doing, I turned around and screwed up. It's probably was wrong with the first time I did this thing. Let me play with this thing. If I shift, and I'm sorry about the mistake at home if I'm confusing you. If I shift that 3Q over, it's going to be P plus 0D minus 3Q equal to 0. So look, I'm guilty of the same mistake. Now that's going to change this line right here in my matrix to 1, 0, negative 3, 0. That's going to make all the difference in the world. 1, 0, negative 3, 0. All right, so I went back to my matrix. I played with it, quitting out. Second matrix, math, reduce row echelon form. Second matrix, A, enter. Perfect. This is what I want. So my guess is the first time I did this, there was nothing wrong. It was just me. I don't claim to be perfect, but I'm usually smart enough to figure it out. So this top line says X, which lined up with pennies over here, is 18. That guy lined up with dimes. Dimes is 14. And the last line lined up with quarters. There's 6 quarters. And if you do the math, that's $3.08. All right, what's up on the next one? The next one is a piecewise function. A cell phone plan costs $15 and includes 2 gigabits of data. For each gigabit of data after, that should say 2 gigabit, that needs to be fixed. User pays $5.50. Write a piecewise function modeling the cell phone plan. So it is a piecewise function. It has 2 pieces to it. Cost as a function of, let's say, data. You're going to pay $15 so long as the data that you use is less than or equal to 2. If the data is less than or equal to 2. I hope you understand that line. No matter what, you're paying $15, right? The next one is going to be 15 plus 5.5, and this is the part that throws kids off. You have to say D minus 2 because you already paid for 2 gigabits of data right here. You don't want to charge somebody for it twice if the data is greater than 2. That's real world piecewise functions. They actually are used in the real world all the time if you stop and think about certain things. Electricity is one of them too. You pay less for a kilowatt of electricity for usually the first 1,000 kilowatts than you do after that. It really goes up. It's actually on a scale. It bumps up and bumps up. All right, what's up with this one? Oh, evaluating a piecewise function. That's pretty simple. Find f of 12. You got to plug that in right there. So negative 2 times 12, take away 12, should be negative 36. You can check the math on that if you want. F of 3 would have to go into this piece right here because x is stuck between 3 and 6, and it has no choice but to be negative 5. It's a constant function. F of negative 1 has to go in the first piece because it says x is less than 3. And that's going to yield, I think, a negative 4 when everything's said and done. All right, making some progress here. Moving on to 7. Shown below are the graphs f of x and g of x. For what value of x is f of x equal to g of x? This is a give me question, the ones you're not supposed to miss. Can a kid look at a graph? That's all it's asking. We have equality when x is 2 and when x is 4. We have that. That's when graphs intersect. That's what it's asking. Where do they intersect? It amazes me how many kids struggle with this, but we intersect when x is 2 and we intersect when x is 4. 2 answers. It's the intersection of a quadratic and absolute value. 8. Graph f of x equals negative 2 times x plus 3 squared minus 4. So this thing right here is in that form a times x minus h squared plus k. She has a vertex at negative 3, negative 4. So on the little grid you're going to have to draw, you're going to go back 3, down 4. You're going to put a nice good point right there. What else do we know about it? Well, we have this. This is my initial slope. I'm sure you can read that at home. My initial slope is negative 2, which means that I can fall 2 units and run 1. Fall 2 units and run 1. So there is my little parabola. Not a hard one. Next one is using the intercept technique. It's in the form of y equals a times x minus p times x minus q, where p and q are x-intercepts, better known as roots and so forth. So we are going to cross the x-axis. It looks at like a -2. Hopefully you're familiar with that now. You've been doing the cover-up technique. And at 4. Need an x-intercept at -2. I need an x-intercept at 4. Now, you have to find the line of symmetry. The line of symmetry is smack dab in the middle, okay? There's a formula for that too. The x-coordinate of the vertex is at p plus q over 2. So at -2 plus 4 over 2 is going to spit back a 1. And if I have x, I find the y-coordinate by plugging it in. So I'm glancing off the equation to the right, or to the left. And I'm going to do the math on this one. I'll have a -2 times 3 times -3, which is 18. So my y-intercept's way on up there. It's way on up there. I'm not surprised by where it's at. I'm just going to pick a point and call it 18, by the way, because I just don't have enough paper. Because the thing has to open down. And if I'm going to pass through these zeros or these x-intercepts, well, I guess it doesn't matter which direction it opens, but it has to open down. 10 graph y equals x squared plus 6x minus 5. You can do this one by factoring, or you can do it by finding the coordinates of the vertex. I'd just go after the vertex. The x-coordinate of the vertex is opposite b over twice a. So that's going to be a -6 over twice a 1, which is -3. And then to find the y-coordinate of the vertex, you just plug some crap back in. And again, you can use a calculator on your test, so, don't be afraid to use your calculator. Rather large, isn't it? It's going to be a large number. It's not that bad. That's 9 minus 18 minus 5. Assuming I'm doing everything right, I'm pretty tired. That should be -14. So when I graph this thing, I'm going to have to go to the left 3, and I'm going to have to fall to -14, and I just don't have enough time to do that. And here she is. One thing I forgot to do on the last, well, actually I did do it on the last one, but the one above here, I forgot to draw the line of symmetry in on that one. I should have done that. There's my vertex, -3, -14. The line of symmetry passes through it. And I actually want to go after the y-intercept. To find a y-intercept, you let x be 0, because it's really easy to do with this equation. Y would be 0 squared plus 6 zeros add a 5, which is 5. This thing crosses the y-axis at 5. 1, 2, 3, 4, 5. And then I can use symmetry. I have a point 3 units to the right. There's got to be a point 3 units to the left. Put it about right there. And there is my parabola. Now, whatever you have to graph on your test, the numbers will be a little bit smaller because, you only have so much room to graph. Can't give you an entire sheet of paper. And the last one that I'm going to do for a minute is going to be number 11. Rectangle has a length x minus 7, width x plus 3. If the known area is 39 square centimeters, solve for x by completing the table. So the reason is area is length times width. So I'm actually going to write the statement 39 is x minus 7 times x plus 3. The next reason is the double distributive property, so probably some foiling. X times x is my x squared. X times 3 is 3x. And then minus 7x. 3x minus 7x is minus 4x. And then we have 3 times -7 minus 21. So there's line 2. Oh, wait a second. I actually was not supposed to put that here. I forget how the state of Tennessee does things sometimes. They actually don't usually, when they use two-column proofs for algebra, they actually don't tend to do a whole lot at once. So sorry, I just write the results of FOILing. The next step is given as combining like terms. So that's where I add the 3x and the negative 7x together. This says rewrite in standard form. Hopefully what you're thinking about is that zero product property. I have to be set equal to 0. So I am going to take 39 away from 21, and I'm going to get a negative 60. And then it tells me to factor. The reason is factoring, so I'm factoring 60. 60 is 6 and 10. There's lots of other factors. I mean, there's 4 and 15, there's 6 and 10, there's 2 and 30. But anyways, a pair that works is going to be 6 and 10. So it takes an x and an x to create x squared. A 6 and a 10 will get me to 60. Why'd I pick them? Because 6 minus 10 is negative 4. Then I hit it with the zero product property, the cover-up method. I say that 0 is x plus 6 or 0 is x minus 10. This gives me solutions of x equals negative 6 or x is 10. And then it says throw away the extraneous solution. So if I take this negative one up here, I'll have negative width and negative length. So the actual real solution is x equals 10. It's real. Okay? And x equals negative 6 is extraneous, not because it's negative, because of what happens when you plug it in. So there's my real answer. I'm going to stop there for